Okay, when this bleaching powder is added to water, CaOCl twice, it is dissociate into calcium and 2 OCl ions, and these when it is react with water, 2 HOCl ions, that is hypochlorous acid, and calcium hydroxide is forming. So if the calcium hypochlorite itself is dissociating, that means without reacting with water, we know there are 2 ions, that is calcium and OCl ions, and when this calcium hypochlorite it reacts with water, it is dissociating into hypochlorous acid, that is HOCl ions and the calcium hydroxide. And now the hypochlorite ions so dissociated combine with the hydrogen ions present in water to form hypochlorous acid, that is HOCl, and this process is known as hypochlorination. That is the hypochlorination. Now bleaching powder is a white powder. It contains about 30 to 35% of active or available chlorine. It is very unstable and hence to be kept in dry condition and not exposed to atmosphere. The bleaching powder is to be applied in the solution form. That means the bleaching powder you have to apply in the solution form. It is usually recommended for small water supply schemes only, and the usual dosage is about 0.5 to 2.5 kg per million liters of water. That means it is 1000 for 1000 cubic meters, or 1000 cubic meters, it is how much? It is 0.5 to 2.5 kg per million liters, or 1 mld. Is it 1 mld or 1000 cubic meters? And bleaching powder, you all know, usually it is being used for our in household purpose also. Whenever we are cleaning our dug wells, we used to put bleaching powder after that, is it? And it is a common substance. And now the second form of this chlorine, that is chloramines. The chloramines are the compounds of ammonia and chlorine. These compounds are stable in water and are found to possess disinfecting properties. The chloramines formed, that is monochloramine, that is NH2Cl, then NHCl2, that is dichloramine, and nitrogen trichloride, that is NCl3, at different pH values. So that means the chloramines, the compounds, it is a compound of ammonia and chlorine, and these compounds are stable in water and are found in and are having this disinfecting properties. So these chloramines are formed in different forms, that is monochloramine, then dichloramine, and nitrogen trichloride at different pH values. This that is another form. Then free chlorine gas, that is the third form of chlorine. The chlorine can be applied in gases. The chlorine can be applied in gaseous form or in liquid form. So usually we know the chlorine is usually, not only usually, always the chlorine we can buy, or we can it is available in gaseous form, and this gaseous this gas, when it is mixed with water, it can be in the liquid form. And the former case, or if it has to be applied in gaseous form, the chlorine gas is dissolved in a small quantity of water, and then the solution is fed to the water under treatment of disinfection. If it is to be applied in liquid form, the chlorine gas is converted into liquid form by applying pressure on it. When chlorine gas is subjected to a pressure of 7 kg per centimeter square, it is converted into liquid form, and the liquid chlorine is stored in cylinders. The apparatus or device which regulates the chlorine dose to be added to water is known as chlorinator.